Let's take a look at compound interest. Interest is what you get when you multiply your principal times your rate times your time. If we're assuming for 1 year, then your interest is your principal times your rate times your time, or if it's 1 period where your time is 1, it's just your principal times your rate. In simple interest, the amount in the account, which we tend to call A, is going to be your principal that you started with, plus your interest, which is your principal times your rate times your time. So if it's for 1 year, just principal times rate. 2 years, you get the same interest that you did originally, because with simple interest, they're not giving you interest on anything but the original principal. So if you get $30 interest the first year, you'll get $30 the second, $30 the third, $30 the fourth, no matter how long you leave it there. Notice we could take the P's out, factor that out, and leave 1 plus RT. Now with compound interest, where it's compounded annually, once a year, the first year, you're going to have your principal plus your interest, which will just be your principal times your rate, because this is 1 year. So at the end of the first year, you've got your principal times 1 plus your rate. Basically, if you're getting, say, 6% interest, at the end of the first year, you have 106% of your principal, because you have 100% of your principal plus the 6% interest. Now, on the second year, you're now getting interest on your new principal. This is your new principal. The principal times 1 plus R. So say 106% of your original principal. So you've got your principal, P times 1 plus R, plus the interest on this, which for the second year is your principal times your interest rate. This is your principal. This is your interest rate. So your interest is your principal times your rate. But notice that this and this match exactly. This is basically times 1. So I could factor out the P times the 1 plus R. And if I take that out, it's going to leave 1 plus R again. So at the end of the second year, you've got P times 1 plus R squared in the account. At the end of the third year, your new principal is now this. So here's your principal, P times 1 plus R squared. And to that, you're going to add your new interest, which is your principal, P times 1 plus R squared, times your interest rate. And so once again, I can factor this out. So P times 1 plus R squared which when I take it out, since this is times 1, this is times r, we'll leave that times 1 plus r. So at the end of the third year, you now have in your account P times 1 plus r cubed. And this will work again and again and again. So rather than calculating it separately for every single year, which would get kind of old if you left it there for 10 years, at the end of n years, you're going to have P times 1 plus r raised to the n. Well, let me change that. They actually use n, they tend to use n as being the number of compounding times per year. So let me call this t years. So at the end of t years, the amount in the account is P times 1 plus r raised to the t. This is actually a formula for annual interest compounded, or annual compound interest. If, here's your compound interest formula, the amount in the account is equal to the principal times 1 plus r raised to the t, where A is the amount in the account after t years, P is the original amount in the account, so that does not change. You can't backtrack and change how much you had in the account. R is the annual interest rate. It's always given as an annual rate. They tell you you're getting 6% per year. Now, a lot of times your account will receive interest which is compounded at certain intervals during the year. So it could be compounded yearly, or semi-annually. That would be twice a year. Quarterly, that would be 4 times a year. Maybe monthly, that would be 12 times a year. Or even daily, and daily is considered to be 365 times a year. They don't worry about leap years. Because the interest rate is given as an annual rate. You don't get that interest rate every single time it's compounded. If you're getting 12% per year, that equals 1% per month. Or 3% per quarter. So if it's not done on an annual basis, you have to take your interest rate and divide it by the number of compounding periods per year. So we use n as the number of compounding periods per year. However, where t is the number of years, if it's compounded 12 times a year, then at the end of the year, it's been compounded 12 times. At the end of 3 years, it would have been compounded 36 times. So we have to take the number of years and multiply it by the number of compounding periods per year to get the total number of times it was compounded. So this is your usual compound interest formula. This takes care of it no matter how many times it's compounded per year, no matter what the interest rate is, no matter what the number of years is, no matter what the original principal was, no matter how much it has at the moment. But A and T are going to be your variables. These are the numbers that'll change and that actually go together. So let's look at an example. Suppose $5,000 is invested for 3 years at a 6% interest rate, compounded, how about quarterly? Then how much would be in it at the end of the 3 years? So here's our original principal. Here's our time. Here's our rate. And quarterly means n equals 4 times a year. So the amount in the account is going to be 5,000. Remember, we've got amount is P times 1 plus R raised to the NT. So 5,000 times 1 plus, oh, this is divided by N, sorry. 0.06 divided by 4. Each time it's compounded, we get 1/4 of the 0.06. Raised to the 4 times 3 power, because by 3 years, 4 times a year will give us 12 compounds. So when you simplify this, first of all, you want to divide out your fraction here. .06 divided by 4. This is going to be 1 plus 0.015 raised to the 12th. Well, 1 plus 0.15 is 1.015 raised to the 12th. Now, this part you have to figure out how to do it in your calculator. The fancier calculators are actually going to have menus, and this may be in a menu somewhere, but typically you're looking for a key that says x raised to the y raised to the x, or just a caret. This caret is the same thing that you find on your keyboard if you hold down the shift key and hit the 6. So it's the 1 over the 6. So that's why they use it sometimes on a calculator. So if you know how to do this in your calculator, you're in good shape. If you don't, you're stuck. To enter this in my calculator, I have the 1.015 in the calculator showing. Mine actually has a y to the x key. So I hit that, and then I hit the 12, and then I hit the equals. So raised to the 12th equals, hold up. If you forget to add the 1 to it, it makes a mess. Okay, 5,000 times, I get 1.19561817 is most of it. And then just do times 5,000. So at the end of 3 years, I would now have $5,978.09. Almost $6,000 in 3 years, $1,000 interest nearly. Sometimes they will call this the present value formula or future value formula. When they give you how much you need in a few years and they want to know how much you have to start with, they just change the name of the formula. It does not change the formula. It's still going to be A equals P times 1 plus R over N raised to the NT. The only difference is in this case, they're going to give us a value for A and ask us to figure out how much we have to start with given a certain rate, number of compounding periods, and time to save. So if we need to have $6,000 in 5 years, and we can get 3% interest rate, I don't know, let's say compounded monthly. How much do we need to deposit today under these circumstances so that it will grow to $6,000 within 5 years? So what we don't know now is actually the principal. So we're going to end up with 6,000. We don't know the principal. It's 1 plus the interest rate. I always change that to a decimal. Compounded monthly. So that'll be 12 times 5. So 6,000 is equal to P times is 0.0025 plus 1 would be 1.0025 raised to the 12 times 5 is 60th. So we've got 6,000 equals P times this raised to the 60th is about 1.1616. You think that's going to repeat, but no, it's a 782. So I'm going to divide both sides by this number. I'm sure I don't need this many digits. Now, one thing I can do to cheat a little, I've already got this number in the window. So I can do this number divided by 6,000 and then hit 1 over X. In other words, I got this in the window. Instead of erasing that and starting over, I can do this divided by 6,000 and then hit the 1 over X key, which will give me the reciprocal, so it'll flip it back over. So I'm going to do that divided by 6,000 equals 1 over X is going to give me 51.6521 is equal to the principal I need to start with to have 6,000 5 years from now. Now suppose $5,000 grew to, I don't know, $6,500 in 7 years. We'll simplify it, compounded annually. And we need to know what the interest rate was. This was the trickiest one typically to solve. We have the A, we have the P. 1 plus R, well, this will be annually, so it's going to be just 1 plus R. Raised to the T is 7. When you've got a situation where you have both the A and the P values, I would suggest you divide those out. So I've got 6,500 divided by 5,000. This gives me 1.3 equals 1 plus R raised to the 7th. I can't get a hold of the R unless I can get rid of this exponent 7. So if I will take the 7th root of each side, these are going to cancel. To do the 7th root, your calculator should have an xth root of y or a yth root of x, or some of them just have like this and don't even have anything in the radical. Now make sure you're not using the square root. Square root's altogether different. We need a 7th root. And some calculators make you put the 7 in first. So you might, to enter this in your calculator, have 1.3 and then the xth root of y, and this may be your second function over your power key, 7 equals, or I have seen calculators where you have to put the 7 in first. Which would be a completely different answer if it uses the first number as the radicand, the thing in the radical, and the second as the index, or changes that around. You must know your calculator. And what you do is you start with an answer to which you know the answer. Start with a problem which you know the answer to. We know the cube root of 8 is 2. So figure how to enter this in your calculator so that you get the 2. So in my calculator, I have the 1.3 in the window. I hit the second function, the xth root of y, 7, equals, it gives me 1.0381918, That's equal to 1 plus r. So r is going to equal just the decimal part here. They typically want this entered as a percent, and of course rounded. Change it to a percent first. change it to a percent first before you round. So if it says round it to 2 decimal places, you change this to a percent first. It'd be 3.81918 rounded to 2 decimal places is going to be 3.82%. So interest is kind of fun to play around with. There's a lot of different versions of the problems they can give, but once you figure out how to use your calculator, which is the main key here, then they're really not that hard. They're calculator problems, and you have to be able to use a calculator to do these.